Alright, so that was proficiency number 13. Here's number 14. There's a guy named Chatlier. What he said is that when a change is imposed on a system at equilibrium, the equilibrium will shift to lessen the effect of that change. Maybe I paraphrase a little bit there. But there's basically three main things we can do to a closed system in equilibrium. Right? We can change the concentration, meaning add more, take more away. We can change the volume, meaning expand the container, contract the container. Or we can change the temperature, heat it up, cool it down. Alright, let's talk about concentration. So you're looking at some nitrogen and some hydrogen making some ammonia. One of the most important equations I think around, a super important equation. Anyways, remember how equations or how reactions happen. Nitrogen and hydrogen, they're all floating around, and when they smack into each other, you get ammonia. And then every once in a while, ammonia is going to break up back into nitrogen and hydrogen as well. So, if you add more nitrogen or hydrogen, you're going to have a higher probability of them smashing into each other, so you're going to make more ammonia, so your equilibrium is going to shift to the right, meaning you're going to make more ammonia. If you put more ammonia in there, there's going to be more ammonia to break up and form hydrogen and nitrogen, so your equilibrium is going to shift to the left. So for adding stuff, basically if you add it to one side, your equilibrium shifts the other direction. And then it's just the opposite when you take something away. If I took away something from this side, there would be less stuff smashing together to form ammonia, so equilibrium would shift this way. So, problem. Correct. So if you add CO, you're adding to the right, it's going to move to the left, and then you don't count solids, so nothing's going to happen, so it's B.
Yeah, Freddie explained it to us.
Okay. It's not the actual volume that matters, it's the pressure that matters. But the easiest way for us to impact pressure is to decrease the volume or increase the volume, right? So, an increase in the pressure is going to increase collisions. So, you have 4 moles of gas on the left. Right? 1 here, 3 here, 4 on the left. You have 2 on the right. So, there's a lot more stuff on the left-hand side. It's more densely populated, like New York. Whereas this got a lot less densely populated, like Alaska. So if another catastrophe happened to the Earth, and both of those countries of Alaska and New York were shrunk to half their size, where would all the people run to? Alaska. Right? They're already standing on top of each other in New York. At least the city. There's actually some pretty nice countryside. But anyways, so this has got a lot more stuff going on, a lot more atoms, a lot more people, however you want to think about it. Whereas this is not. This one's some more space. So if you crush it, you're going to make them move to the right. If you expand it, they're going to move to the left. Because Alaska is a lot of open space for a reason nobody wants to be there. Right? If you have a choice, you want to be in New York because there's a lot of cool stuff going on. Ask Jay-Z, he's a fan. Okay. So, you have 2 on the left and 1 on the right. So more populated on the left. So if you squish it, it's going to hurt the guys on the left more. So the equilibrium is going to shift to the right. So we have 2 types of reactions, endothermic and exothermic. We kind of already talked about these, right? Endothermic is it requires energy for the reaction to take place. Therefore, your Q, your energy, is going to be on the left-hand side of the equation. Exothermic creates energy when it have to write like igniting gasoline. So therefore, energy is a product that's going to be on the right-hand side of the equation. So then, it's almost like a concentration problem then. If you add heat, you're just adding to whatever side your Q's on. If you're cooling down, you're just taking away from whatever side your Q's on. So for instance, this is endothermic. So your Q is over here on the left. Q plus N2 plus O2. So if you heat this up, you're adding to the left, so it moves to the right. If you cool this down, you're taking away from the left, so it moves to the left. So it's just like a concentration problem, except you just got to know where your Q is. Endothermic is on the left, exothermic is on the right. Exothermic means your Q is on the right-hand side. So if your temperature is decreased, you're taking away from the right-hand side, so your equilibrium is going to shift to the right. Filthy sneaks.